Hello everybody, right, today what we're going to be looking at is quite a common fault on trucks, which is the puffer light coming on, SCR system, which stands for Selective Catalytic Reduction, and we have a warning light on the dash. And most commonly these faults are normally associated with either the dosing unit itself or NOx sensors, which are quite common. So what I want to do today is show you some basic checks, how to check the NOx sensor, how to check that the harness going up to the NOx sensor is okay, and to determine whether it's actually physically a sensor fault or a harness fault. Okay, as you can see, what we've got is we've got the puffer light flashing, workshop warning sign coming up on the dashboard. I've got the Ansel scan tool here, so if you're going to diagnose, we're currently on the Volvo and we're going through the 1708 CAN bus line. 1708 on the Volvos is their diagnostic line, so don't pick 1939. If you go back, you'll pick 1708. And what I've done is, if I go back to here now, I'll show you. I've come into the engine system. The engine system, its module number is 128. There is a specific one here for the after treatment system, which is mid 233. But for some reason, this scan tool does not want to go in via that module, so we're going to have to go in via the engine control module. Select it. We're going to look at the trouble codes, read codes. Let's see what we get. And as you can see there, present high NOx, root cause unknown, special instructions. So here is the NOx sensor on the exhaust. If you follow the loom back, there is the module. Now the modules are connected by a plug which has got 4 wires on it. Positive, negative, CAN high and CAN low. And normally what I do, essentially this sensor, what it does is the data from the sensor gets converted into a CAN message. And that CAN message through the CAN wires goes back to the network which has the dosing unit on it, or the actual module itself. You can see the module at the back here with the plug into it. So first basic check we do is with the ignition off, as I'm going to check the CAN wires. And a good CAN circuit, as we've already mentioned before, if the CAN circuit is okay with the ignition off, we should have 60 ohms physically coming up to this module, and that will prove that the module itself is connected to the CAN line, and it will show whether there's any faults or some faults on the CAN line. It shows if there's any broken wires or any resistive issues. So what we've done, we've connected the multimeters to pins 1 and 2. I've got the multimeter set on resistance, and there you can see nice and clear 61.4, which is close to 60 ohms. It shows that the CAN network, the 2 wires are okay, there's not a high resistance, and we've not lost a terminating resistor. So that's your first check there. We now know that that module for the NOx sensor is connected to the CAN lines. But what we haven't determined yet is whether the module has a feed power supply and a good ground, and we can also check with an ignition on if any of the CAN wires are shorted to a high or low source. So that's our next check. Next check, going to pins 3 and 4. Pin 3 is the 0 volts, pin 4 is 24 volts, or the supply. The multimeter is telling us there's 25.3 volts available at the module. Only issue with this is we haven't put a load onto the line, so if there is any resistive faults with the power supply, the multimeter isn't going to show it because the multimeter doesn't put enough draw on the line. So just now with that plug off, you're not going to see a voltage drop, because in order to see a voltage drop you need a current flow and the resistance, which we don't have as soon as we disconnect a plug. So for belt and braces, what we're going to do is put a bulb across it, 21 watt, and make sure that the power supply can physically light a bulb. So I've connected the bulb, nice and bright. So we've got a good strong feed, 24 volts and a good earth coming up to the module. And the next check we're going to do is check to see if we have the correct voltages at CAN high and CAN low. Okay, next check, we've got the multimeter set to volts, DC. I'm using the earth in the plug, which was pin 3. I've got the red lead of the multimeter plugged into pin 1, and that is giving us nearly 2.5 volts, so that's our CAN high. The fact it says 2.5 shows that it's not shorted to ground. If it shorted to ground it'd be 0, and it shows that we're not shorted to high source, i.e. 24 volts or any other higher voltage system rather than 5. So what we'll do now is we'll check pin 2, which is CAN low, and make sure that that is okay as well. So let's go into pin 2, and there you go, look, just slightly less than the CAN high. So we know both CAN lines are okay, they're not shorted to ground, they're not shorted to high source, we don't have high resistance. We know that the unit itself, the module's got a good 24 volt supply, it can light up a 21 watt bulb. So we've pretty much determined that the cabling going to the NOx sensor is okay. If you still have an issue with that NOx sensor, then it has to be the sensor itself. It is not the cabling coming up to it. Right, so what I'm going to do is we're going to connect this entry-level picoscope to the CAN high and CAN low on the NOx sensor module, and I'm going to show you what a good scope trace is. So if you go down to the actual loom itself, you can see I'm connected to pins 1 and 2, which is CAN high and CAN low, and of course each channel on the picoscope has to have an earth, so I've connected it to the earth on the battery, and I'll show you how to set up the picoscope. Right, when I'm using the 2204A, what I'm going to do is I'm going to use picoscope 6 here, double click it. Now remember, I've already got the tool connected to the loom. Let's see what we get. Now when we're using this, because we're on a 5 volt circuit, I don't need to worry about putting attenuators on this, because remember, the 2204A is only able to take 20 volts in per channel. But that's for another day. So what we've got is, let's go auto, select 5 volts, and I'm going to switch on channel B, select 5 volts. You can see just now we've got something happening on the screen, but what I'll do is I'll bring on the trigger, and I'm going to set a repeat trigger. I'll bring up the wee diamond, the target here, and then you can see, look, we've got a nice CAN bus trace. So if I pause that for the time being, you can see the two of them are starting at 2.5 volts. I can prove that by bringing down one of the measures here, roughly 2.5. If I go to the top of CAN high, look, it's going up to 3.5 volts, and if I go to where CAN low drops down to 1.5. So that is a nice CAN trace, and incidentally, you've got starter frames as you've got each message coming up here. But ultimately what we're looking for here is to make sure that none of these wires are shortened to ground. We've got a nice even or symmetrical image coming up, and the voltages are within range, so 2.5 to 3.5 and then 2.5 to 1.5. Right guys, so what we've done is we've proved the loom's okay, we've proved that the NOx module is getting a feed, it's getting good connection to CAN bus. We've since replaced the sensor, and now we're going to go in, clear the codes, make sure that the puffer light goes out, and hopefully everything then is all up and running. Okay, so I've gone back into the engine control module, I've cleared the codes, they all went historic, I've cleared them, and as you can see, whoo, the puffer light is now out. Until the next time, speak to you soon.